Hello everyone, welcome to my channel. So in this video we will discuss another previous year question paper, section A problems. One mark question, choose the correct answers. Let's see the first problem. Here the first problem is root 3 plus 2 whole square plus root 3 minus 2 whole square is an or a positive rational number, B negative rational number, C positive irrational number, D negative irrational number. So root 3 plus 2 whole square plus root 3 minus 2 whole square, we have to prove, we have to say whether what type of number it is, whether it is a positive rational number, whether it is a negative rational number, or negative rational number or positive rational number. So after solving it we will know what type of number it is. Let's try to solve it. So now the given question is in the form of a plus b whole square plus a minus b whole square, right? So root 3 plus 2 whole square plus root 3 minus 2 whole square means it is a plus b whole square plus a minus b whole square. Let's check what do we get for that. A plus b whole square plus a minus b whole square is equals to, here a plus b whole square, a square plus b square plus 2ab plus, so here a minus b whole square, a square plus b square minus 2ab. So here plus 2ab minus 2ab gets cancelled. Now we have a square plus a square. It is 2 times of a square plus b square is 2 times of b square. So if you take 2 common, we will get 2 of a square plus b square. So this is the value. Now let's write what is given. Root 3 plus 2 whole square plus root 3 minus 2 whole square. So what do we have to write? 2 times of a square plus b square means 2 times of a square. A square means here a is root 3. So root 3 whole square plus b square. Here b is 2. So 2 square. So now it is equals to 2 times of root 3 whole square is 3. 2 square is 4. Now it is equals to how much? 2 into 3 plus 4 is 7, which is equals to 14. 14 is a positive rational number. So which option is right here? Option A is right. So option A is right here. 7 is a positive, sorry, 14 is a positive rational number. The second question is, let x is equals to a square b cube c power n and y is equals to a cube b power m c square, where a, b, c are prime numbers. If LCM of x and y is a cube b power 4 c cube, then what is the value of m plus n? So here x prime factorization is given, y prime factorization is also given, and LCM of x and y is also given, this one a cube b power 4 c cube. Then what is the value of m and m plus n? So to find m plus n value, we have to find m value and n value first. So let's write what is given first. What is the prime factorization of x? Here it is given that x is equals to a square b cube c power n. So what is the y? A cube b power m c square, right? So what is given here? LCM is given. LCM of x and y is given as a cube b power 4 c cube. So what is LCM of n? What is the formula? LCM of x and y, product of greatest powers of all the prime factors, product of greatest powers of all the prime factors. So equals to, already LCM is given, right? So a cube b power m, sorry, b power 4 c cube. Now, so product of greatest powers of all the prime factors. So here it is given that in a square and a cube. So a cube is greatest. So we can write here a cube. And in b it is b cube and b power m. So here we don't have, here we don't have b cube, right? We have b power 4. That means definitely this value will be b power 4. So this is equals to b power 4. So b power m. Next, here we have c cube. So here we have c square. So definitely this will be c cube. So if you compare the LHS and RHS, what do we get here? 3 and 3 both are same. In place of 4 we have m. In place of 3 we have, so this is n, right? So this one is n. C power n. This one is c power n. Yes. So now in place of 3 we have n. So m is 4, n is 3. So what we have to find? We have to find the value of m plus n, which is equals to 4 plus 3 is equals to 7. So 7 is the right answer. So where is that 7? So in second question, so option B is right answer. Next, third question is, for any prime number p, if p divides a square, where a is any real number, then p also divides what? So if p divides a square, then where a is any real number, then p also divides what? Your options are given: a, option b, a whole power 1 by 2, c, a power 3 by 2, d, a power 1 by 8. So if p divides a square, then p also divides what? For example, let us think that, so let a is 4, let a is 4 and p is 2. So here, what is a square value? A square value is 4 square, which is equals to 16. That means this a square is divided by p, means 16 is divisible by 2. Okay, when a square is divisible by p, then what about a divided by p? A is 4 divided by p is 2, so which is equals to 2. That means if a square is divisible by p, if a square is divisible by p, then a is also divisible by p. So for that, option A is right answer. So next question is, which of the following equation is a quadratic equation? So we have to check every of this option and find which of these is a quadratic equation. So let's write the first option. Let's take the first option. What is the first option? Option A. It is given that x square plus x square plus 1 is equals to x minus 1 whole square. So x square plus 1, here apply a minus b whole square formula. A square plus b square minus 2ab, minus 2 into x into 1 minus 2ab. Now it is equals to x square plus 1 equals to x square plus 1 square is 1, here minus 2 into x into 1, so it is minus 2x. So left side, so do one thing, send all these left side things to right side. So 0 is equals to, if you send all things to right side, it becomes 0 is equals to x square plus 1 minus 2x already on the right side. If you send this x square right side, it becomes minus x square. If you send plus 1 right side, it becomes minus 1. Now here cancellation is cancel, we can cancel these things, plus x square minus x square, plus 1 minus 1 gets cancelled. Now what do we have? We have left side 0, right side minus 2x. So it is not a quadratic polynomial, it is a linear polynomial. So option E is not right. So let's take option B, right? So what is option B here? So option B is this one. What is that? X plus root x whole square is equals to 2x root x. Left side apply a plus b whole square formula. A square plus b square root x whole square plus 2ab, means 2 into x into root x. So a square plus b square plus 2ab equals to right side as it is 2x into root x. Now x square plus root x whole square, square root and square gets cancelled. Now it is only x plus here 2 into x into root x. So it is equals to 2x root x equals to 2x root x. If you bring that right side 2x root x left side, becomes what? X square plus x plus 2x root x already on the left side. If you bring that right side things to left side, it becomes minus 2x root x equals to 0. Now this one gets cancelled. Now what do we have? We will have x square plus x equals to 0. So it is a quadratic equation. So when it is a quadratic equation, no need of checking the option C and D. So which option is right here? So option B is right. So option B is right for fourth question. So next fifth question is, if x square plus bx plus b is equal to 0 has two real and distinct roots, then the value of b can be. So what is the value of b? If this equation has two distinct real roots, what it can be? So let's write what is given first. So what is the quadratic equation given here? X square plus bx plus b is equals to 0. So let's compare this one with the general quadratic equation. So what is the general quadratic equation? Ax square plus bx plus c is equals to 0. Now what is the a value? The coefficient of x square here is 1. So a is 1 and coefficient of b here the same. B is equals to b only. The coefficient of b is same. Now constant term c is equals to b. C is equals to b. Now when this equation has two distinct real roots, the discriminant value should be b square minus 4ac should be greater than 0 when it has two distinct real roots. So let's apply a value, b value. So b square, so here b value is b only, minus 4 into a value is, what is a value? 1, and c value is b, so is greater than 0. So b square minus 4 into 1 into b, it is 4b greater than 0. So let's take b common from the both the terms. So if you take b common from the both terms, now you have b of b square minus 4 equal to 0. That means product of b and b minus 4 greater than 0 means both should be positive. If you multiply b and b minus 4, we should get a positive number. When we get positive number, when b and b plus 4 have the same sign, means same plus or same minus. So two cases are possible. They can have same sign, they can have both positive sign, they can have both negative numbers. So that means case 1. What is the case 1? B can be positive greater than 0 and b minus 4 can be greater than 0. Both can be greater than 0 means both are positive. So here if you send b minus 4 right side becomes b should greater than 4. So remember this, b should be greater than 4. And case 2, both can be negative. That means b can be less than 0 and b minus 4 less than 0. If you send minus 4 right side becomes what? So b should be less than 4. So in the options, do we have these values? Let's take case 1. If you take case 1, should be greater than 0. So here this option B is greater than 0. Option C is also greater than 0. B should be greater than 4. Here there is no value which is greater than 4 here. So not 0, which is not 0 is greater than 4, not 3 greater than 4, not 4 greater than 4. So now let's go for the second option. So case 2. What is the case 2? So this one, b can be less than 0, b should be minus 4, sorry, less than 4. B should be less than 4 and b should be less than 0. So what is the number less than 0 here? So what is the number that satisfy both these one? B should be less than 0, b should be less than 4. Only this option D, which is less than 0, minus 3 is less than 0. Only this option D will satisfy case 2. So option D is right answer. Now let's see the sixth question. What is the sixth question? In the figure given below, points PQ are divides the line segment AB in the into four equal parts. Means AP part, PQ part, QR part, and RB part all are same. Means the lengths are same. So what is the ratio here? AP is one part, PQ is one part, QR is one part, and RB is another part. So this PQR divides AB into four equal parts means all are same. Now the question is the point Q divides PB in the ratio. This Q, this Q divides PB in the ratio. This only P to B. This one. We know that to the left side of Q we have one part. To the right side of Q we have two parts. That means this Q divides this AB in the ratio 1 is to 2. To the left side of Q there is a one part, to the right side of Q there are two parts. So Q divides PB, just it is given in the only PB, so P to B distance. So to the left side of Q one part, to the right side of Q two parts. So Which option is right? 1 is to 2 is the right answer. So option C is right answer. So next, seventh question is, a bag contains red balls, black balls in the ratio 3 is to 7. So red balls is to black balls is 3 is to 7. A ball is drawn at random. The probability that ball so drawn is black in color. So what is the probability of getting a black color ball is what we have to find. So here the ratio is given. So number of red balls to number of black balls is given. So when the ratio is given, let us take x as the highest common factor for number of red balls and number of black balls. So here the ratio is given, right? So let number of red balls be, red balls is equals to, here red balls are 3 parts. So let us think this is 3x, and number of black balls. So number of black balls are 7 parts. So it is 7x. Now how you get the probability of black balls? P of B is equals to number of black balls 7x by total number of balls. Total number of balls are red balls plus black balls. So the probability of black balls is equals to number of black balls by total number of balls. So red balls plus black balls. So it is equals to 7x by 3x plus 7x, 10x. So x cancel here. We will have 7 by 10. So 7 by 10 is the probability. That's it. So which option is right? 7 by 10 means 0.7. So which option has this 0.7? So option C is right. Next, eighth question is, so what is the eighth question? Which of the following statement is false? Two right triangles are always similar. So it is false. So they might have different angles or different sizes. So two right triangles are always similar is false. Two squares are always similar. So it is true, because in all the squares all the angles are equal. Each angle is 90 degrees. So they can be similar by angle similarities, no problem. So because they will have same shape, right? When the two try when the squares have same angles, they will have the same shape. Definitely they will be similar. Two equilateral triangles are always similar. In equilateral triangles each angle is 60 degrees. So they are also similar. So this is also true. Next, two circles are always similar. So all circles are of same shape. So therefore it is also true. So only option A is false. So option A for this question is right answer. So next, ninth question is, in the adjoining figure ABCD is a trapezium in which XY parallel to AB parallel to CD. So here, so what it is given here, this XY parallel to AB and XY is also parallel to DC. So these three lines are parallel to each other. Now it is given that, what it is given, AX is equals to 2 by 3 of AD. So this is also given. So we have to find CY is to YB. So this one, CY is to YB. Okay, let's try to find. So to find this one, we have to do one thing. join D and B. So let's join D and B. Let us think these two, this DB and XY meet at some point O. So now in triangle DAB, XY is parallel to AB because XY is part of XY. So according to basic proportional theorem, if a line is drawn parallel to one side of a triangle, then it divides other two sides in the same ratio. So what you can write from triangle DAB, from triangle DAB, this XO divides DA side, DB side in the same ratio. That means we will get DX by XA is equals to DO by OB. So let this equation 1. Now from the triangle DBC, so this one, from the triangle DBC, OY is parallel to DC. From the same basic proportional theorem, you can write DO by OB is equals to CY by YB. So equation 2. From equation 1 and 2, what you can say? So here we got DO by OB and DO by OB. When these are equal, then these two will be equal. So what are the equals here? So we will get dx by xa is equals to cy by yb. So let us keep it aside. Let us think this is 3. Now write what is given. So first of all, what is given here? Ax is equals to 2 by 3 of AD. So it is given that Ax is equals to 2 by 3 of AD. So bring 3 left side, becomes 3 times of Ax is equals to 2 times of AD. Bring 2 left side, it becomes 3 by 2 Ax is equals to AD. Now send Ax right side. So 3 by 2 is equals to AD by AX. Now here this AD can be written as dx plus XA. So dx plus XA. So in place of AD you can write dx plus XA. So 3 by 2 is equals to, so in place of AD you can write dx plus XA by AX. Now separate the denominator. We can write dx by this AX can be written as XA. No problem. So AXA plus XA by XA. We have separated the denominator AX for both the numbers dx plus XA. Now here it is equals to 3 by 2, right? So 3 by 2 is equals to dx by XA. Now what is this value? XA by XA value is 1. So if you bring that one left side, so if you bring one left side becomes what? 3 by 2 minus 1 is equals to dx by XA. So here multiply this 2 and 1. Now we'll get 3 by 2, sorry, 3 minus 2 by 2 is equals to dx by XA. So otherwise we can write dx by XA is equals to 3 minus 2, so 1 by 2. But from equation 3, what is the value of dx by XA? So dx by XA value here is cy by yb. So dx by XA value is cy by yb. So let's write cy by yb. So in place of dx by XA we can write cy by yb. Cy by yb is equals to 1 by 2. So cy is to yb is equals to 1 is to 2. So this is the right answer. Let's check which option has this one. So ninth question, 1 is to 2. So option D has this one. 1 is to 2 is the right answer. So next 10th question. What is the 10th question here? Which of the following statement is false? Infinite number of tangents can be drawn to a circle. So is it possible to draw infinite number of tangents to a circle? Yes. So if you have a circle, you can draw infinite number of tangents. So we can draw tangents at every we can draw tangents at every point on the circle. So infinite number of tangents can be drawn. So this option A is true. Next, what is this option B? Infinite number of tangents can be drawn to a circle from a point outside the circle. From a point outside the circle, is it possible to draw infinite number of circles? Infinite number of tangents? Let's check. Option B. From a point outside the circle, is it possible to draw? So let us take a circle. So from a point outside the circle, right? So let us think point B. So we can draw only two tangents to the circle from a point outside the circle. So option B is wrong. So this is false. Next, infinite number of secants can be drawn to a circle from a point outside the circle. From a point outside the circle, we can draw infinite number of secants. Secants means a point that touches the circle at 2 points. So from a point, we can draw infinite number of secants. So these are all secants that touches the circle at 2 points. So option C is also true. So already we got option B is right answer, but anyhow, let's check this option C and D also. So option C is true, and option D, angle between the tangent and diameter of a diameter at a point of contact is 9 degrees. Yes, the angle between the tangent and angle between the tangent diameter is 9 degrees. So we know that. So so this is the diameter and this is the tangent at this point. So we know that angle between the tangent and the radius is always 9 degrees. So here it is 9 degrees, then therefore angle between the tangent and diameter is also 9 degrees. So this is also true. So only option B is false. So for this question, which option is false means it is option B is false.